Hi, I'm Dr. Nijisha Chajal, Assistant Professor from the Department of Biomedical Engineering, SRM Institute of Science and Technology, Katanglathur. So in this course, Principles of Medical Imaging, I'm going to discuss about Unit 1, X-ray Imaging and Digital Radiography. In that, I'll be discussing the topics of collimators and grid, automatic exposure control, the photocell method and ionization method, the visualization of X-ray, X-ray film, fluorescent screens, X-ray image intensifier tube, and X-ray image intensifier system. Let's start the session. So we are going to see what I mean by collimators and grids. So the X-rays are coming outside. How do and you're getting an image? How do I improvise image? For this, two important components you have. They are the collimators and the grids. So one is nothing but to increase the image contrast. The other one is to reduce the dosage to the patient. We'll see one by one. And these two devices, first device that we are going to see is the collimator. So what is the collimator? It is being placed between the X-ray tube and the patient. So you have the X-rays which are X-ray tube which are giving the X-rays. It is going to fall on the patient. In between you have a filter. That is nothing but your collimator. It is nothing but a lead shape. What is the structure made up of lead, and this will nothing but it will give you the shape in which the X-rays has to fall. So if you want a small shape, then naturally the lead will be small. The sheet will be a small sheet. If you want the X-rays to fall on a larger surface area, then you spread the lead sheet and then the area will be more. So that is the basic concept. Okay. Why do I need this is if in case I want to get a high contrast image, then the X-rays have to be concentrated, the energy has to be concentrated. Naturally, I need to give a small surface area. Whenever I want, my priority is not contrast, but I want to know the different structure. In that case, I can go for a large area output. Okay, so this is the main difference between the main advantages of using collimator. So it is directly, what you say, they are indirectly dependent on each other. So it in a low dose to the patient and simultaneously it increases the image contrast. So the scattered radiation, it reduces the diffuse. So whenever the area is more, scattering happens, and so the image intensity, what you say, the clarity will get reduced. This is how a collimator looks like. So you can see here the rotating anode, all this, and from here you have the X-rays to be produced. Now instead of sending the whole X-ray, you are going to use this collimator. This is your collimator. So how when you adjust this collimator, you get a defined sheet. So you can see here, this is the useful beam. So only in this area you are going to give it. So if you change, you push it, you get a smaller area, bigger area like this. This is the collimator device. So they are nothing but lead. Okay, so these are all made up of lead. So they'll block the X-rays. They are all in the form of a shutter. So whenever you want to decrease it, you bring the shutters close. Whenever you want to increase it, you can increase it. So this is how they are arranged. You can see here, you can increase it. This area will increase. You bring it close, they'll become smaller. So this is how it is done. In order for us to see, because X-rays are not visible by eye, they actually use a collimator light, and so that we can see how the X-rays are. So you can see, like, if people have taken, you can see a green line. This is nothing but to help us know where the X-rays will fall. The second important device that we are going to see is nothing but called as a grid. Very, very important difference is that the grid is a device which is being placed between the patient and the film cassette. So you have the patient, X-ray is going to cross the patient, it's going to fall on a film. Where your X-rays, the balance residue X-rays are going to come. In between that, you are going to place a grid. Why do you use it? Is to reduce the loss of contrast due to scattered radiations. The grids are nothing but when it falls on this, again scattering takes place. To avoid that and to avoid scattered radiation going and falling on the, what you say, in the sheet, we use this grid. What are grid? They are very, very thin lead strips. They have a space. Why do we use this? Now the X-rays, you have an image here. So X-rays, they are coming here, you have an object and they are falling. Now what happens is when X-rays, they cross and they fall, you have scattered radiation along with the actual absorbed radiation coming out. Scattered radiation, the radiations will not be straight. It will be here and the half a sun. So what we are doing is we are going to place a grid, something like a block, in such a way that only the electron which are coming straight will pass across the broad. So the very, very thin sheets of lead. So in between the X-rays will fall, but if it is scattered here and there, this lead sheet will absorb it. So scattered radiations are absorbed and only direct radiations which are passing out will come. So this is the main advantage of using grid. And this is placed so that you get only the useful radiation. You reduce, you avoid the scattered radiation. Okay, this grids, no, what happens is when these grids are kept like that, in the image you can see a particular line coming, correct? Because X-rays are falling, in between you have this one, so naturally X-rays in this region will not be seen. So people at the later stages, they started moving the grid, like we do the sieving, no, like that we have a rice and we sieve, same way they do. In that case, what happens is you call it as a bucket grid. So it's a very important device in an X-ray machine. The next important component of an X-ray machine is your automatic exposure control, which is nothing but, now exposure means how much ever is X-rays which are coming out. So all this, how can I exposure, how I can control it. So how for selecting the appropriate X-ray exposure, it depends upon the patient size, the shape and the physical condition. Now examination projection to be performed. Now imagine I'm giving I want to take an image of the hand. For that I need not give a very high exposure, high energy X-ray radiation or high energy, high area radiation. All this has to be automatically controlled. So if the person is thin, for him less energy is enough. If a person is fat, then naturally I need to give a more higher energy. So all this can be controlled using an automatic exposure control. How it is done? With the help of a photocell, and another one you have using a ionization chamber. We'll see how a photocell depends on. Okay, in case of photocell, a fluorescent detector is placed on the exit side of the patient. So the patient's exit side you're going to place behind the radiographic cassette, which monitors the X-ray intensity transmitted through the film stream. So now this is all with respect to the previous step. So previous step you had a film, X-rays will fall on the film, and the film you have to develop it to see it. Now what you do is, behind the film in the bottom part you're going to keep a photocell. Photocell is nothing but like our detector, no, camera detector. So in that case what happens is, you once your X-rays have fallen into your sheet, your cassette, this photocell will pick up those X-rays as its visible rays, and it will immediately tell the switch, no, to switch it off. Okay, the circuit will control it to control the X-rays exposure and turn off the radiation. This is how it works. So you can see here, you have the X-ray tube, you have the patient, you have the, so collimator comes between the X-ray tube and the patient, and grid comes after the patient and the cassette. So now what happens is, after the cassette you're going to keep a photocell. If the X-rays reaches the photocell, automatically you record it and you tell the generator to stop it. So this X-ray stops. Okay, this is one way of automatic exposure control. And the second concept is by using an ionization chamber. We already know that X-rays, they can ionize. So what do we do? So instead of this X-rays which are supposed to go to the cassette, no, you place an ionization chamber in between the grid and the cassette, and whenever X-rays are detected, immediately you give a timer, and after the timer you give it to a generator to stop it. That's all. So what happens is, after some time, you know that X-rays started coming out, after some time you switch it off. So this is something like again another type of automatic exposure with the help of an ionization chamber. Let us go to the next topic, which is visualization of X-rays. There are three ways in which I can visualize it. So one way is by the help of an X-ray film, which is like all of you who have taken X-rays can see a film, and that is one way. Second thing is, if through a fluorescent screen, something like this, you have people who have used DSO, you can see that fluorescent screen. The third one is with the help of an X-ray image intensifier TV. This is nothing but real time you are going to see it. So these are the three ways in which you can visualize it. X-ray film, you have a film. Okay, so what you're going to do is, X-rays, they are short wavelength, high energy, so you cannot see it directly. So what you're going to do is, you're going to make it react with the photographic emulsion of film. Now when this film, no, when this X-rays goes and falls, it will react with it and will give a different reaction. Okay, so that reaction you're going to see it out. That's all. So this is made up of light sensitive emulsion, which is silver halide crystals. So silver halide, when it is exposed to visible light, what happens is the Ag ions, they are reduced and they are converted into metallic Ag. Okay, metallic silver. Now what happens is when this X-rays falls in this, wherever it is exposed, you will have in one color and the other areas will remain the same. Now this exposed, you are going to chemically develop it. The exposed film, which is not chemically developed, contains a latent image consisting of a pattern of invisible halide grains with the latent image centers. Now what happens is when you have the film X-rays fall, you have a different type of thing which you cannot see it. Now you need to process it. You need to process it when you improve it. Whichever has been exposed to X-rays can be seen. So what happens is that in that area, whenever the X-rays fall on it, different, if it is falling lesser, you will have it in white color, like that you have to assume. If it is totally fallen, it will become black color. So just to think is, it's a silver film, silver white color film. You are allowing X-rays to fall on it. If X-rays totally fall on it, becomes black. If it doesn't fall, it becomes white, like that. When totally it doesn't fall, it becomes total white, like that it will be. Okay. How you can sensitize it? By improvising it. Okay, so what happens is when visible light falls, no, that can create some illusion. Sometimes what do they do is they use something like this, sandwich it in between, and that can be seen. Okay, so that is also another way it is possible. That is called as a intensifying screen. Intensifying screen is where you have this screen sandwich in between, and when you see it with light, no, with the light you can see the fluorescence and you can view it. The ideal screen fluorescent material, it must be blue color. Okay, so it must be somewhat like blue color in color. So this is how it is, and these are the different ways in which it is being sandwiched. So when the X-ray photons fall, so in one way is directly X-ray, you allow it to interact it and you give a color. Second way is like you convert the X-rays into visible light, and visible light you are going to give it to a visual, to a fluorescent light, and then that you're going to see it. The second way is nothing but the fluorescence. Like I told you, what X-rays you cannot see, you're going to convert X-rays into visible light, and that you're going to see. That's all. So the fluoroscopy, you're going to use a fluorescent screen. How do you do? It is nothing but fluorescent material, zinc, cadmium sulfide. All these are available. It is viewed through a glass plate. So the zinc, cadmium sulfide is present. So how we are going to do is, you're going to allow the X-rays to go and interact with it, produce visible light, and this visible light you're going to see it. But the only disadvantage is that the room must be dark. Only then you can see the visible light, because it falls, you get a glow. You fall, it glows. The X-rays fall, it glows. So it has to be a very small duration, and within that time you're supposed to see the X-ray. You cannot see it after that. Okay. Whereas in case of X-ray film, it is a film, you get it as a photo. Okay. The last one is your image intensifier television system. So this is nothing but, again, you're going to convert it to this image. How do you do it? Same process, but you're going to view it. You're going to record it. So here you can see. So for that, what you're going to do is, again, X-rays you have. X-rays, you're going to allow it to follow on a photocathode. So what do you mean by a photocathode? This X-rays will get converted into electrons. So X-rays are photons. You're allowing the photons, the light atoms, no? So the light, materials, no? The light units to fall on an atom, and this atom will produce electrons. Now for each light X-rays, you have one like that multiple electrons are ejected. This electrons, you are going to speed it up. Again, you are going to accelerate it. How? With the help of accelerating electrons. So you have here, so you have the anodes, dinodes you call. So multiple anodes you have, which will speed it up. You will focus it. At this point, what happens? All the electrons gets focused, and then here comes the anode. So in the anode, what happens is it boosts and it falls here. Again, you have a target output phosphor. When the electrons goes and bombards, you have visual light to be seen. That is as a visual image you see. Again, as a visual photon it is being seen. So this is the X-ray image intensifier tube. So what happens now? Real time will be able to see. Okay. The electrons with high kinetic energy, they produce light quanta, which you can see it as a much brighter, but it will be a small output image. Okay. and this can be seen more clearly. So this is how this is. So you have the X-ray tube, you have the patient, it falls on this photocathode, then this four dinodes, and then the anode. Here you're going to, whatever is the display, you're going to record it with the camera and you're going to see it. That's all. So before, previously in older generation, they used to use something called Vidicon. Now directly you can use the camera, you can record it, you can see it, you can replay it. Everything can be done, but this is all in discussion with the previous types. Okay. Now we are using is a CCD, that is normal camera, charge coupled device camera, where you're going to record it and with very, very high resolution, around 2048 cross 2048 pixels. Okay. And photoconductors are used for reducing the energy, everything we use nowadays, everything is a high specification X-ray system that we are talking about now. So you can see the CCD chip, you have the X-rays, these are getting, so this is how the whole tube looks like. So you can see here you have the X-ray tube, you have the collimator, it is falling, you have the grid, the CCD system, and that can view the subject. Okay, with this we'll end today's session.